Have you ever stopped to think that behind every spoonful of Nutella, there is a whole orchestra of industrial processes, logistical decisions, and rigorous controls spanning several continents and thousands of people? For that flavor you recognize instantly to reach your table, more than 1,300 tons of hazelnuts, around 700 tons of cocoa, and approximately 500 tons of powdered milk are required each year. On the first production line, enormous hydraulic presses squeeze the cocoa paste until it transforms into compact discs weighing around 7 kilograms each. But before reaching that point, there is a fascinating journey that we are going to explore in detail. The story of Nutella begins in scarcity. During the Second World War, cocoa was a limited and costly item. A pastry chef from Piedmont, a region in northern Italy abundant in hazelnut trees, decided to mix crushed nuts with the scarce cocoa paste available. The result was an unprecedented flavor bar introduced in 1946. Over time, the formula evolved, adopted a creamy format, and crossed borders. Today, it is estimated that more than 360,000 tons of the famous spread are sold each year. Its silky texture and its balanced aroma of cocoa and toasted nut make it a culinary wildcard. Spread, fill, combine, and of course, eat by the spoonful. Although Italy prides itself on its hazelnut tradition, the largest proportion of hazelnuts used comes from the foothills surrounding the Black Sea in Turkey. There, sloping plantations extend like green tapestries among hills, taking advantage of microclimates that favor uniformly sized fruits with a high oil content. When the fruits ripen, the pericarp dries and the hazelnut falls to the ground. This is the moment for aspiration harvesters, self-propelled machines equipped with vibrating combs and vacuum turbines that lift only the ripe caps, minimizing mechanical damage. The material passes into a side hopper where fans separate leaves and branches. Once out of the field, the loads are transferred to metal hoppers fitted with sensors that record weight, humidity, and temperature. A belt driven by rollers carries them to a vibrating sieve that calibrates size, while optical detectors discard broken pieces. Next comes an ionized air blower that removes dust and possible inert residues. This first screening ensures that, upon arriving at the processing plant, the hazelnuts maintain their physical integrity, avoiding rancid or bitter flavors in the final product. Before being admitted to the lines, quality personnel take a representative sample. With a surgical steel guillotine, they halve hazelnuts to inspect the kernel's tone and the presence of internal channels, a sign of moth or fungus. Complementarily, a multispectral camera system analyzes the outer layer, identifying mycotoxins not visible to the human eye. Only approved batches continue. The rest are destined for lower-value byproducts or the cosmetics industry. The approved hazelnuts go to a pneumatic peeler. A jet of hot air under pressure fractures the fruit's cuticle, while a rotating drum removes the shell. They then enter forced convection ovens set to 105 degrees Celsius uniformly. Inside, helical paddles move the kernels to avoid hot spots. The roasting profiles are regulated with time temperature curves. A slow 20-minute rise optimizes the release of volatile compounds, pyrazines and aldehydes, responsible for the characteristic bouquet. Infrared sensors monitor color and humidity in real time. Toasted and fragrant, the hazelnuts fall into ceramic disc mills where they are pulverized into a homogeneous paste. For a smooth mouthfeel, 98% of the particles must be smaller than 40 microns. This parameter is verified with a laser granulometer. The degree of liquefaction facilitates the natural oil's emulsion with the rest of the ingredients during mixing. The other aromatic pillar of Nutella originates on farms in Côte d'Ivoire, Ghana, and Nigeria. Farmers cut the pods with curved machetes and extract the seeds wrapped in white pulp. After fermenting in wooden boxes for 5 to 7 days, a crucial stage for developing flavor precursors, the beans are spread on jute mats under the equatorial sun. After about 10 days, they reach 7% moisture and are bagged in breathable jute. The maritime route takes them across the Atlantic to the nearest European port to the plant, where laboratories check microbiological parameters. In the factory, vertical silos dose beans into cylindrical, double-jacketed roasters, rotating at 60 revolutions per minute. Hot air at 140 degrees Celsius develops caramel notes without burning the interior nib. After roasting, shelling rollers separate the shell from the nib. The nibs are ground into cocoa liquor, a dense fluid rich in butter. To obtain powder, this liquor is pumped to hydraulic presses at 500 atmospheres. The fat fraction drains and crystallizes separately, while the resulting cake cools and breaks into 7-kilogram discs. Finally, ultrafine milling reduces them to dark red powder. Although Nutella does not contain butter or fresh cream, it uses spray-dried skimmed milk to provide proteins that act as emulsifiers. Fresh whey undergoes vacuum evaporation to concentrate the solids. It is then sprayed in drying chambers where hot air jets at 180 degrees Celsius evaporate the water almost instantaneously, forming hollow microbeads that dissolve quickly when mixed. To ensure spreadability without solidifying at room temperature, certified palm oil is used, largely sourced from Malaysian plantations with RSPO certification. The fruits are sterilized in autoclaves to inactivate enzymes that would generate acidity, pressed and deodorized at 240 degrees Celsius under vacuum. The result is a colorless, tasteless, contaminant-free oil ready to interact with cocoa and hazelnut without stealing the show. Everything converges in stainless steel tanks with variable pitch tri-blade agitators. First, the hazelnut paste enters, followed by palm oil preheated to 45 degrees Celsius. When the emulsion reaches the desired viscosity, superfine sugar, sifted to avoid clumps, is dosed. Next comes degassed cocoa powder, while Cowles-type turbines ensure enough turbulence to break any flocks. Powdered milk and a concentrated infusion of Madagascar vanilla are added at the end to preserve aromatic notes. The blend rests in isobaric maturation for about 4 hours, during which slow agitators prevent phase separation. The mixed Nutella paste then passes through a 5-roller refiner train. Each roller exerts less pressure than the previous one, and together reduce the mean particle size from around 40 microns to between 15 and 18 microns, the threshold below which the tongue can no longer perceive granularity. Inline laser sensors monitor granulometry and automatically adjust the gap between rollers if it falls outside the range. The flakes exiting the refiner are sent to horizontal conches maintained at 60 degrees Celsius. For about 12 hours, a partial vacuum extracts moisture and volatile compounds. Then the mass is gently aerated while adding lecithin, 0.3%, to stabilize the emulsion. Slow stirring favors controlled fat crystallization, expels bubbles, and yields a final viscosity of around 3 pascal-seconds. The result is a homogeneous, glossy cream so fluid it is described as liquid silk, ready for tempering and packaging. Before releasing a batch, panels of trained tasters evaluate color, shine, aroma, and spreadability at 20 degrees Celsius. Simultaneously, gas chromatographs detect aflatoxins under strict limits, and spectrophotometers confirm that the hazelnut to cocoa ratio meets internal standards. If everything matches, a robotic arm seals the batch with date, time, and lot number. Nutella travels in its iconic glass jars. Recycled glass is melted at 1,500 degrees Celsius in regenerative furnaces. Pistons cut incandescent droplets that fall into steel molds and take their final shape under compressed air blowing. To avoid stresses, the jars pass through an annealing arch where the temperature drops from 560 degrees Celsius to room temperature in 40 minutes, ensuring resistance to thermal shocks. The cream, kept at 42 degrees Celsius to preserve optimal fluidity, is directed through sanitary pipes to volumetric fillers calibrated with a margin of error of plus or minus 1 gram. Internal pistons synchronize with the conveyor to dose up to 300 jars per minute. Each nozzle descends about 4 millimeters into the jar, sufficient depth to avoid splashes and bubble formation, and retracts slowly while injecting the exact amount, ensuring a uniform fill level throughout production. Immediately afterward, pick-and-place robots install threaded caps containing a heat-sealable aluminum disc. When the jar passes under the induction station, a coil generates an electromagnetic field that selectively heats the foil. The thin polymer layer melts and adheres to the glass rim, creating an airtight seal that preserves aroma, prevents leaks, and acts as a tamper-evident indicator. Pressure sensors verify closure torque, and vision system cameras discard any unit with sealing defects or fill level deviations, ensuring that only perfectly sealed jars proceed to labeling and final packaging. The jars move to labeling stations that apply shrink sleeves with multilingual nutritional information and a QR code. Each corrugated cardboard case is printed with a traceability identifier linking to the factory database and showing everything from the hazelnut plot to the filling line. Robotic palletizers organize the boxes and wrap them in stretch film. Finally, refrigerated trucks, between 18 and 22 degrees Celsius, head to global distribution centers. The fat extracted during cocoa paste pressing is channeled entirely to new uses. Part is sold to artisanal chocolatiers and bonbon makers who appreciate its shine and melting point. Another fraction is incorporated into cosmetic formulas, from lip balms to body creams, thanks to its moisturizing power and stability against oxidation. The light shells from hazelnut peeling also do not end up as waste. They are stored dry and then burned in biomass boilers that generate steam for ovens and process lines, covering a significant portion of the plant's thermal demand and cutting thousands of tons of carbon dioxide per year compared to fossil sources. This total utilization model is part of a broader environmental strategy. Nurseries and reforestation projects are funded in cacao and hazelnut supplier areas. Premiums are paid for certified quality, Rainforest Alliance fair trade, and producers are trained in agroforestry and biological pest control. Thus, byproducts become valuable resources. The factory reduces its carbon footprint, and farming communities increase their income and resilience. This is how the production of one of the world's most beloved creams is orchestrated, a technological ballet that transforms dispersed raw materials, nuts, cacao pods, milk, and vegetable oils, into a homogeneous, consistent product ready to accompany breakfasts, desserts, and cravings at any time. Every phase, from the gentle fall of a hazelnut in Anatolia to the snap of the lid sealing, is designed to make the result predictable and delicious. The next time you spread Nutella on a slice of bread, remember that you are carrying centuries of pastry tradition and the most modern food engineering converging in a single spoonful.